Okay. All right. So the next two sections, 7.4 and 7.5, are going to be all about vectors that we're going to be talking about. And you might, if you've taken physics before, you guys have talked about vectors. We're going to do just the basics of it in this class. We don't go too far in depth. So we've actually got these two lessons over vectors. Then we have two other lessons over polar coordinates, 7.6 and 7.7, and then one lesson on parametrics. We have 5 more lessons left, and that's it. Then you have your final exam. There will be a couple quizzes over these little things, but no test over these things. You'll just see them on the final as far as points go. Okay. I feel like yes. One of them was. I had it on the calendar. Next Friday, well, next Thursday, we're doing a vector escape room as a quiz review, and then next Friday is an open note partner quiz. You'll be able to use these notes on your board next Friday. Yep. And then, yeah, the other quiz is also open note partner. So both quizzes are open note partner. 2 more quizzes. One.
What's the final exam?
I feel like
Multiple choice or is it?
I think it was half and half what we did last year. Like one day was multiple choice, one day was extended response.
No shot. You got a picture of the vector?
Yeah, okay, we're getting to that. We're getting to that. Okay. All right, so what is a vector? So most quantities that we talk about in math can be represented with a single number. Like if I'm talking about jelly beans in a jar, I might have 30 jelly beans. That 30 describes the quantity that I'm talking about. But some things need 2 different pieces of information to describe them, and those are what we call vector quantities. Vector quantities have a numerical part, but they also have a direction. So if there is a direction included, then we also are going to call it a vector. Okay, so an example, common example is wind. So wind has, in this example, 15 miles per hour. That's the strength. That's the number quantity. And then you also have southwest, and that's the directional piece that goes along with it. When we draw a vector, it's going to look like a ray that you guys drew back in geometry. So it's going to have a point on one side, and it's going to have an arrow on the other, and that arrow is going to show the direction that it's represented. The length of the ray, it's going to have an initial point where it starts and a terminal point where it stops at the very tip of the arrow. The length of the ray is going to be the quantity. So if I was measuring that 15 miles per hour southwest, my vector would be 15 units long, whatever my unit was, and then it would be pointing in the direction of southwest. Okay? All right. So, yes, I met Vector. There's me and Vector at Universal Studios like 5 years ago. He didn't understand. I'm going there again this summer, so I'm kind of hoping I'm going to see him. He's my favorite. I need a Vector shirt, I feel like, to go that day. So Vector is going to be the villain in our escape room next Thursday, this Vector. So we're going to have to... Okay. All right. You let me know how that works out. All the planning of that. Okay. There will be a vector. That vector, we are going to foil his plot next Thursday. He's going to be involved. I don't know if he'll be here. I guess you'll find out.
Someone dresses up as
That would be pretty great. With the orange jumpsuit. Can you see her walking in here? She would. All right. So let's keep going. Let's keep going. All right. So the magnitude, sometimes they're going to use the word norm. Our book uses magnitude more often, is the length of the vector. When you see 2 bars on either side of a vector name, and vector names are going to be bold-faced most of the time. You may also see, they call this vector V. You may also see 2 capital letters with an arrow over them. So vector PQ, you can see in the picture here, P is where it starts, Q is where it ends, and the arrow is going from P to Q. So that tells you the direction of the vector. So you might see it written that way, or you might see it written with just a bold-faced letter. The bold-faced letter will be lowercase. If you see 2 bars on either side of it, that means magnitude or length of the vector. One thing we talk about first are equivalent vectors. Equivalent vectors have the exact same length and the exact same direction. So there's a few examples here, some sets. These ones are what we call opposite vectors. They're the exact same length, but you can see the arrow, the terminal side is on the other side. They're flipped. So those are what we call opposite vectors. This is an example of equal vectors, same length, same direction. Then we've got obviously ones that are different lengths and different directions, so they're not equal. So you might see a Math Excel question that asks about equivalent vectors, equal vectors. That's what you're looking for, same length, same direction. Okay. All right. We do have one special vector. The special vector is called the zero vector, and it's denoted by a boldface 0. It has no magnitude, 0 magnitude, and we say its direction is arbitrary. So if you have a vector of length 0, it means it starts and stops in the same spot, which means we don't have a direction from one point to another. So we just say that vector has an arbitrary direction.
Uh-oh.
Okay. Hello. Thank you. Ryan.
Nice. One of your bad, bud.
It's right here.
Oh, right here. What's that do?
All right, and that next little paragraph is a little picture of opposite vectors. Opposite vectors, we're just going to put a negative in front of one to get to the other. Okay, so we are going to add and subtract vectors. How we add vectors is we add from tail to head. Okay, so where one stops, its tail, the next one begins. So if I wanted to add vector v to vector w, I would sketch vector v, whatever its length and direction is, and then I would attach vector w to wherever v ends. So we make like a little train with our vectors. The sum, or we use the word resultant of the two vectors, so resultant mean sum, is the vector that connects the initial point of the first vector to the terminal point of the last vector. So this diagonal in the middle of this parallelogram. Sometimes this is called the parallelogram theory. Then you can also do it the other way. You can see if I take vector w and add vector v, I get the same result. So what this picture tells me is it doesn't matter the order that I add vectors in. V plus w is the same as w plus v. We're going to see a lot of v's and w's and u's in this lesson. We're going to be sketching these in a second on your screens. All right, an example of vector subtraction. If I wanted to do vector v minus vector w, we think of it as vector addition with a negative. So instead of v minus w, I'm going to think of it as v plus the opposite of w. So how that would work is, I'm just going to kind of sketch it to the side. We'll do this with graph paper in a minute. I would sketch vector v. Okay. And then to that, I would add on the opposite of w. Well, w right now is going to the right and up a little bit. The opposite of w is going to go in the opposite direction. So it's going to go to the left and down a little bit. It's going to look the same as vector w, but the arrow is going to be on the other side. And where I attach that, I start it where vector v ends. So vector w, opposite of w, is going to go right there. Okay, so we're making a little train with the vectors. Your resultant, or sum of the two, is going to start where your first vector started, and it's going to end where your last vector ended. And it's important where your vector ends that you put an arrow there, because that tells us the direction of that new vector. So what you see in red there is v minus w, a new vector that we've created. So when we're doing this, you can think of this as like combining two forces together. If I, let's say I push this desk, and I push with a certain amount of force, that's my magnitude, and I push in a certain direction. So I'm pushing the desk towards Julia, okay? Julia is going to push the desk also at the same time, and she has her own magnitude force that she pushes with, and she has her own direction. So maybe I'm pushing it this way towards the back of the room, and she's going to stand over here and push the desk that way. Where's the desk going to go if I'm pushing that way and Julia's pushing that way? It's going to go towards Brody, right? It's not going to go my way. It's not going to go her way. It's going to be a combination of the two. And who's ever pushing harder, whatever magnitude is larger, their direction is going to win out, right? Make sense? Probably Julia. Okay. So that's what we're doing when we're finding a resultant. My answer is a new force and a new direction that we're creating when two things are added together. We can also do scalar multiples of vectors. Think about this as like a dilation. You guys did that in geometry. We're just stretching and shrinking. So if I have vector v, 2 times vector v, you can see same direction. It's just doubled. Half of vector v, you can see same direction. It's just halved. And then negative 2v, we doubled it, but it's going the opposite way. You see that negative in front of it. All right. So let's sketch some vectors here.
Yeah.
All right, we're going to do these 3 together, and then on the next slide, you guys have some to practice on your own. At the top, there are 3 vectors that are sketched for you, u, w, and v, and if you can't see it very well, I'm going to kind of emphasize what the arrows are on the end of those terminal points there, there, and there, okay? These do not go on forever. They have this specific length that you see. All right, first problem we need to do is vector u plus 3 times w. So first thing I need to do is sketch vector u. These are just kind of floating around in space. There's not a certain point where you're going to start at. This isn't an xy plane where we have to always start at the origin or something. All right, so I'm going to pick that as my starting point. Vector u, if I want to sketch it, you can see, think of this like a slope, a rise and a run. I have to go up 1, and I have to run to the right 2. So up 1, right 2. Make sure you put your arrow on the end of it. That's vector u. Okay, then we're going to add on 3w. It's going to start where vector u ended. Okay, now 1w, if I were going to sketch it, I'd have to go down 1, right 1. If I want 3w, we just do that essentially 3 times. We're doing the movements 3 times and making it 3 times as big. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I'm going to get 3w. Okay. The resultant, or the sum of the two, is where vector u starts. That's where my vector is going to begin. And it's going to end where 3w ended. So make sure at that very bottom piece you put an arrow there to show the direction. So if I were like grading this on a test, I would look at this last vector and I would count your rise and run and make sure it's appropriate no matter where this is on your graph paper. So you can double check on your paper. You should go down 2 and to the right 5 for that final vector. And that's vector u plus 3w. Okay. Good. Question so far? Okay, let's do another one. 2v minus u. Remember, that's the same as 2v plus negative u. Okay, so starting with 2v, how do I graph 2v? Double v. So v right now is just 3 units to the right. So I'm going to go 6 units to the right. Okay. All right. Then I need to add on the opposite of u. Well, u is going to start where 2v ended. Okay. If I just use vector u, I go up 1 and right 2. So what do you think the opposite of that is? Down 1 and left 2. And what you should see is a vector that has the same slope as vector u. The arrow's just on the other side. We have an opposite vector. Okay. Connect the 2, get your resultant. 2v minus u. Make sure you have an arrow at it at the end of that one. Okay. All right, one more. 2w we're going to start with. All right, so I don't know where to start this one at. I guess we're going to find out. 2w, I would have to go down 2, right 2. Then I need to add on the opposite of v. Okay, so from where that vector ended, where am I going to move? Left 3. That's the opposite of v. Then we're going to add on 2u. So where the opposite of V stopped, 2U would be up 1, right 2, up 1, right 2, or total up 2, right 4, however you want to think about it. 1, 2, 3, 4. There. Okay, so they kind of cross each other here. That's okay. So my final answer would start at the purple vector and end at the green vector. And actually, that one goes 3 units to the right, so it's actually equal to vector V that we started with. Okay? Make sense? Make a train and connect the start to the finish at the end. All right, go to the next slide. You guys have 3 to try on your own, and then we'll put the answers up. I'll give you a few minutes. Let's see how you did. Okay, so remember, yours don't have to be in the same location as mine, but they should have the same slope and direction. So like this first one, you can double check your answer. You'd have to go down 2 and then 1, 2, 3, 4, 5, 6 to the right. So if your final vector is going down 2 and 6 to the right, you're good. For the middle one, over 4 to the left, over 3.5. This one was a little weird with the half U, so you're half units. 3.5 to the left, and then up 4 would be the final answer on that one. And then this last one, down 4, right 2 is the final vector that we're looking for there. Okay. What questions do we have on these? Adding, subtracting, scalar multiples, geometric addition and subtraction of vectors. Nothing? Okay. Just a couple other little things we can do with vectors, and then we'll finish this lesson tomorrow. We won't do all of it today. Okay. We usually don't like our vectors to be floating around in space. We're going to eventually see some trig functions pop up here, which is why it's in this chapter, in this section, in this class. So we are going to, in most cases, draw vectors as what we call position vectors. Position vectors are vectors whose initial point starts at the origin. And because they always start at the origin, we don't have to list the initial point. A vector can then be described with just its terminal point only, because we know that it starts at the origin. So if you see pointed parentheses are what these are, that is a position vector. So this vector V, I know, starts at 0, 0 and ends at the coordinate V1, V2. But the pointed brackets tell me that it's a vector rather than just a single point. How we calculate magnitude of a vector is essentially the Pythagorean Theorem. We take the first component, we call it, it's kind of like the x-coordinate, square it. Second component, squared, and then square root. You can see that in this picture up here. We're seeing like that right triangle trig start to show up now, okay? So V1 is my x, first component. V2 is my y, second component. Square it, add it together, take the square root, and it gives me the length of what we see as a hypotenuse here, but it's really our vector. So the magnitude formula is not a new vector, new formula. It's just applying to our vectors now. How do we make a vector into a position vector? So let's say we've got this vector PQ that's like floating around, and we want to slide it so it begins at the origin now. So it's not changing its length, it's not changing its direction, we're just moving it. How we move it is with this formula here. So you want to circle that, whatever. Position vector is the following formula. We subtract our x's and we subtract our y's, where those x's and y's are the initial and terminal point of the vector. I remember this is terminal minus initial. So you take the terminal x value and subtract it from the initial x value. That gives you your new x coordinate, your first component. and then you do the same thing with the y values. So we have a little example here. It says let W be a vector with an initial point -2, 7 and a terminal point of 1, -3. So we've got this vector floating around. We want to make it a position vector using the formula. It would look as follows. Subtract your x's, make sure it's terminal minus initial. So the x coordinate from my terminal point is 1 minus the x coordinate from my initial point, -2. And then same thing with your y's, -3 minus 7. So that vector, they're calling it vector W, can be represented as 3, -10. So the vector that starts at 0, 0 and ends at 3, -10 will have the exact same length and direction as vector PQ if you were to draw that picture and connect the dots. All right, so that's going to make some of our calculations easier later. The rest of this at the bottom here, you don't really need to write down. This is straight out of your textbook. We're not going to spend too much time on it. Pretty much it allows us to arithmetically, instead of geometrically, without a picture, add, subtract, and multiply vectors by a scalar component, by a number. Stretch it, do that dilation. So here's a couple examples. You're going to see these are really fast, and a lot of the properties used in Algebra 1 are going to apply with our vectors. If I have vector v is -1, 2, and vector w is 2, -3, I want to find 3w. Think about how we sketch that. It's just w 3 times. So it's going to look like a distribution problem. We are multiplying each component by 3, and that's it. If I want to do v plus w, so we did that earlier with a sketch geometrically. Vector v is -1, 2. Vector w is 2, -3. Think of this like combining like terms. The first components are your x values, so your horizontal. The second components are your y values, your vertical. We combine horizontal with horizontal, vertical with vertical, and that gives me the final movement, and that will give me the length and the direction of that vector. So -1 and 2, if I add those together, my first component is going to be a +1. And then if I add 2 and -3, I get -1. So that is the resultant, algebraically instead of geometrically. Let's say I have this, -4 times v minus w. So we're going to do order of operations with these. I'm going to do v minus w first. Vector v is -1, 2. Remember, minus is the same as plus a negative. I'm going to think of that the same way when we do it algebraically. Okay, so I'm going to simplify inside that parentheses first. Some things that I have to simplify. I'm going to distribute that negative in. So it'll give me a -2 and a +3. And because it's addition, I can just combine my like components together. So -1 and -2 give me a -3. 2 and 3 give me 5. And then distribute the -4 through, and you have your final answer of 12, -20. Okay. Last but not least, I have 2 bars on either side. Remember, the bars mean magnitude or length. The final answer to this problem will be a single number. It is the length of a vector, not a vector. So what we're going to do first is find the vector 3w minus 2v. Okay, so 3w, we did that earlier. That was 6, -9. Instead of minus, I'm going to think of it as plus, and then you can just distribute -2 into v. So that would give me a +2 and a -4. Okay, so 3 was distributed into w, -2 was distributed into v. Combine your like components. 6 and 2 give me 8, -9 and -4 give me -13. That's the vector. Because I have the bars on either side of it, we take it one step further and find the length of the vector. Now, if you need to, you could draw a picture of this. 8, -13 would start at 0, 0, and go 8 to the right and 13 down. Vector would look something like that, rough sketch. We are finding the length of that. This is just a Pythagorean theorem. We know it's 8 on one side, 13 on another. 8 squared plus 13 squared, take the square root, you get your answer. I wouldn't even put the negative in there because everything's positive anyway. So what is that? 233 under the radical. Okay. Questions on any of that? I think we'll stop there for today. Finish up the lesson tomorrow. Sound good? Okay. So if you guys want to tonight, you can start on 7-4. Your current circuit training is over 7-4 and 7-5. That circuit training that's out now is not due next week. It's due 2 weeks from now, that Tuesday. Okay, so you've got a little bit of time because it's going to take some time for us to get through those lessons. 7-4 Math XL is due on the 19th, so next Tuesday night is when this Math XL is due. You can do a little bit tonight if you want to. All right, we will continue tomorrow.